Good morning, afternoon, evening, or night. Welcome to another ElmLive. It's a rainy morning here in San Francisco. It's probably a lot worse for those of you up in Seattle or Oregon or Washington. But welcome, regardless of the weather in your local region. So today, I've been collecting a bunch of responses that people have sent in related to the past projects that we've done on the stream and in the YouTube videos. So I wanted to take a look at a bunch of those and answer a few questions, and if there is anything that anyone wants to ask in the chat as well, we can try to cover that and just see how the day goes. So no big agenda for the day, but there's a bunch of cool stuff that some people have submitted and some interesting questions as well, and we can take a look at a few of those. All right. So the first one to start off with is, let's see, this might be kind of small to read. Karsten wrote in, so this was about the first project that we did on the stream, the Lights Out game. And Karsten wrote in about how to make an automated solver for it. And I'm not going to read through this whole thing because a few days later, he actually implemented it in Elm code. So here's the repository, and you can see a little animation of it. And he uses this Gaussian elimination algorithm that he talked about in his YouTube comment, which is basically where you define ones and zeros, in this case for the Lights Out game, to, or actually I don't know how it works. What I want to do is download this and see if we can run it and take a look at the algorithm he implemented. But the high level of it is that each row and column in this matrix represents one of the cells, and whether it's on or off, or possibly how many neighboring cells contribute to its being on or off. And then you can just use a row reduction algorithm to find a minimal solution and the minimal number of button clicks that you need to press to solve the Lights Out puzzle. So let's see if we can clone this Elm project and give it a try. So this is something we talked about when we made the game on the stream, of how you could potentially make an automated solver. So I was excited to see when someone actually went and implemented it. So let's check this out, and I'll start up Atom while that's downloading. All right, so let's see if we can, let's see, LS-HTML, is there custom HTML in here? Looks like there is. So let's see if we can figure out how to run this project. So I'm noticing there's a main HTML file in here, and it's looking for a file called game.js. So I am going to guess that we need to compile our Elm into this file and then open the HTML file. So I'm going to try running elmmake and presumably compile main.elm and give it an output file and put it into the HTML folder and call it game.js. All right, so it needs to install dependencies. And then let's just see if we can open it. HTML/main.html. Cool. Looks like that's working. So this is basically the same game that we implemented in the first episode of ElmLive, but the difference that Karsten added is the solve button, and it's highlighted in blue all the buttons we need to press to solve the board. So let's try it out. I'm going to click all the blue ones, and it doesn't matter what order you click them in. It's looking pretty good so far. Hey, perfect, we won. And, okay, you can make a new board. Let's see what edit does. Oh yeah, that's cool. And you can just toggle individual cells when you're in edit mode. And, yeah. Let's make our own custom board and see if it can solve it. Oh, I made an unsolvable board. Interesting. Huh. That's really interesting. I guess I would be curious to know some of the rules about what makes it solvable or unsolvable. Yeah, cool. So let's take a quick look at the code and see if we can understand a bit about how this works. And thanks again to Karsten for doing the work to build this, first of all, and putting it up on GitHub for everyone to have a look at. So let's dig into the code. So we have a main.elm. There's a model, which is a game board. There's a solution, which is a list of coordinates. So I'm guessing this is the all the blue cells, or which cells it should render as blue. Cool. And here is a find solution message. So presumably this message is triggered or generated when we click the solve button. So let's jump down here. Find solution. Okay, so there's a solve game board function, which is going to give something back which contains coordinates, and then we just stick those coordinates in the model. Cool, so let's see where this is coming from. Solve game board. That must be in another file. So presumably it's from one of these two. I'll guess it's in game board. And this is a case where when I do imports, I rarely expose everything from a module, because when I'm searching the file, it's nice to have it explicitly listed at the top so that I can know immediately which file when I'm searching within one that references it. So let's guess it's in game board and go check on that. Solved game board and solve game board. Okay, so there it is. It says, uses simplified Gaussian elimination to solve a game board. A solution is just a list of cells that you have to push in order to turn on all the lights. Oh, okay, I guess green means on and red means off in this case. Okay. So this calls solve. And let's look at the type annotation for solve. That is not, oh, there it was. That is in this other Gauss module. Cool. Yeah, so we could find right away where it was coming from because it's explicitly listed here. Oh yeah, and I forgot to mention I'm trying some different encoder settings again. Hopefully we'll have a bit less lag for those of you that were having trouble in the past. But if there's any problems with the audio or video, let me know in the chat, and we can try to fix that. All right, so we're going to look in the Gauss module for the solve function. Solve. Given a list of some items, you can extract Boolean vectors, and this will try to calculate a solution. Okay, so we give it a list of A's, and we give it a function that can turn each of the a's into a vector of bools, and then we also give it a vector of bools, and we get back a list of a's. That's not immediately obvious to me how that works. Let's just look at vector for a moment. This represents vectors as a list of its components. Okay, so it's essentially just a list with some nice functions. Ah, I see. Specifically this one for XORing two vectors of bools together. Huh, okay. And then in Gauss, so where was the solve function again? Here. So how does this work? It takes the span, does an indexed map of the span, so it basically attaches a row number to each of these, or it attaches an index to each of these bools. List.filter, then it filters indices, and it does a solving in there. Let's see how that works. This takes a matrix and gives back a set of integers. Interesting. Cool. Well, I think that's about as far as I want to look into this today. But if any of you all are curious more about the math, I would suggest taking a look at this repo and digging into it and playing around with it a bit more. One of the interesting things I'm noting is that the solvers and the functions in this solving module appear to be doing some optimizations in solving that are specific to solving matrices of bools, which I think is kind of interesting. And there's another package that I was noting when I was doing some research for another project. There's this linear algebra package. Is that actually the one I'm thinking of? No. Here it is. Elm Gauss. Yeah, this is an Elm package that does Gaussian elimination on matrices of rational numbers, so not limited to bools. So you could probably use this under the covers to implement the lights out solution as well. But it looks like the solution that Karsten made is optimized in certain ways for dealing with bools. So that's really cool. So thanks for building that and sharing it with everyone. Let's see, and I will be posting the links to all this stuff later as well. So I guess in that case I should just move this to my other window and save it for later. All right, done with that. Oh yeah, and this is what we were looking at on the Wikipedia page. Cool. Well, I guess I should take a moment to welcome everybody in the chat. Hello. See some new people, and probably some old people. I haven't memorized all the names of everyone who's tuned in yet, or all the usernames even. But welcome. Hope your day and morning is going well. So let's take a look at our next submission. So here was a fix. If you remember when we did the Mandelbrot project, and actually why don't I go and start that up. When we did the Mandelbrot generator episode, we had some problems with the clicking when we tried to zoom in. A lot of the clicks weren't getting registered, or they were offset for some reason. So this one I think we can run with Elm Reactor because there's no custom HTML. And let's load this up. So in main, okay, there's the Mandelbrot. And we were trying to add clicking to zoom in. And actually, I'm going to open this up in the text editor. So here's a submission from J.W. Jones, making a PR that is supposedly will fix the on-click issue. So let's take a look. Interesting. Oh, okay. So I was just trying and debugging some stuff and put this on mouse on. So it looks like he's saying this line height needs to come out and then use this. All right, let's try this out and see if it'll work for us. I'm going to bring up the inspector here as well. And let's make sure we have the right zooming Mandelbrot hooked up. Okay, looks like we do. So let's just look into the code and make sure everything's set up how we expect. So we are supposedly using the zooming Mandelbrot view. So in here, we are calling Mandelbrot.view and passing in a message that we want to produce whenever there's a click. And then we should be getting a debug.log of the message whenever it is clicked. Okay, so that's not currently happening when I try to click in there. And then in the Mandelbrot itself, let's look at our view function. So here's the function we pass to generate messages. On row click, so let's look at view row, and then in view cell, this continues to get passed down into view cell, and here's view cell, and here is where we actually attach that. Cool. Okay, so it's currently not working, so I'm going to try pulling in this commit, or this PR, and see if that fixes the problem. So here are the steps to do that. Check out. I don't think we need to check that out. I'm just going to pull his PR directly into my branch. And cool. Okay, so we should have that change. And yep, it looks like this has changed. And I'm hoping that other line is gone. All right. Oh, cool. Yeah, perfect. So I can now click wherever I want. We can see the message being generated and then the zoom updates. Awesome. Cool. So that is perfect. Thank you, J.W. Jones, for that. And I am going to merge this. Thanks for your contribution. All right, one PR down. All right, and here is another issue that was on the same Mandelbrot project. Poking around in Elm core, I could not come up with any speed up of the incremental Mandelbrot. And this is actually something that I looked into and was able to chat with Evan a little bit about. So if you remember, the issue was we had made this Mandelbrot renderer, and what we tried to do was, like currently whenever I load the page, it calculates the entire frame. It calculates the entire frame all at once before it renders everything. So what we had tried to do was set this up so that it would calculate a single line and then render that, and then sleep for a few milliseconds and then render the next line, and basically break it up so it would render incrementally down the screen. Hey Rollergraph, welcome. Glad to see the chat is working again for you. So there were big performance problems when we tried to set up the incremental rendering. It basically took minutes to do an entire rendering, whereas when we're rendering it all up front, it finishes just in a matter of seconds. So let's see. First, I want to reset to origin master, and then pull in that PR that we just merged. And then let's try swapping this back. So in our main.elm, we had an alternate version of our main declaration, which used the incremental Mandelbrot renderer. And there's a slight problem here because after trying that, we added the zooming later. So now we need to do a little bit of fixing compilation errors before this incremental Mandelbrot will work again. So let's see if we can do that. So let's see, the view is expected to take a model and give back HTML, but it's actually requires a message. Okay. So incremental Mandelbrot.view requires an on-click message. Okay. So let's see, our update function in incremental Mandelbrot takes a message, which is calculate next row. So we're going to need another message type. I'll just make one called do nothing for now. And we'll have to implement that. And in this case, we'll just return the model and command.none. And then I'm actually just going to change this view function to not ask in the onClick. And instead, we'll just hard code it to do nothing inside of here. And it needs a function that takes a coordinate and returns a message. So I'm going to create this anonymous function that always returns do nothing. And okay, and now this returns a specific message type because of this that we're spitting out back again. All right. So now this main file compiles. Let's reload this and see if we have the same performance problem. Oh. Yeah. Okay. So the other weird thing about this was that it also was kind of rendering in batches, which was weird. Like it would asynchronously be doing all of these updates, but it wouldn't re-render the view every frame. And it would take, in certain cases, like a minute or two. Well, maybe not that long, but it would take like 20 seconds before it would even render the first time. Yeah, okay, so you can see the performance problem here. So actually, I was not able to find a fix to this, but I did learn a few things from Evan about the internals of Elm. And what's going on here is the Elm runtime tries to batch up multiple update cycles in between rendering refreshes. The reason for that is that doing the rendering, like the manipulation of the DOM, is the slowest part, from what I understand, in an update cycle. So the Elm runtime tries to do some optimizations and run multiple, like process multiple messages if there are more than one available, and do a bunch of the update processing first before it tries to re-render the next frame. And it has some heuristics to try to guess whether it still has time in the next animation frame time window. It tries to determine whether it has time to run another update call, or if it needs to wait until after rendering the view again to do another update call. And in this particular case, where we have very slow calculations being done when we process each of the messages, the Elm runtime is not optimized for that. So I actually have, as a result of that, I made another branch on this repo called Performance Mystery, and it's still on my to-do list. I'm supposed to email out on the Elm Discuss mailing list to a few people who have worked on performance stuff in the Elm runtime in the past, and give them this as an example of a case where the current runtime heuristic doesn't choose the right thing. So that's something that likely could get fixed in the future, but is also a fairly unusual case where we're doing this heavy computation and then immediately firing off another message to do another heavy computation. But in any case, that was the result of the investigation of why this was so slow, which, if you remember from that episode, we spent a bit of time pondering about and didn't really make any progress on understanding. All right. So that covers all the Mandelbrot stuff. So, before we move on to the next things, I think I would like to take a short break. Give myself a second to refresh on the next stuff that's coming up. So yeah, I am also happy to take some Q&A, and if there's any little things people want to suggest trying to build today, I think we'll probably have time for that a little bit later. So say hi in the chat if you haven't already, and we will take a short break and be back in just a few minutes.